If you just started taking physics and you already feel like dropping the class or just quitting or throwing your hands up in the air, pulling your hair out, don't give up just yet. I'm going to show you by outlining the course why you shouldn't quit just yet. And if you're taking physics for the first time and you really enjoy it, keep watching because I will break down the whole course topic by topic so you get an overview of what's ahead for you. Now, how am I able to do this when I don't even know where you're taking physics, who your professor or teacher is, or even what country you're in right now? Well, the thing is, 99.9% of all physics classes follow the exact same outline, and it's just the nature of the beast because physics is a subject that builds upon itself. So we all need to start at a certain point and we keep building topic upon topic as we progress through the course. Then there is of course some room for variation, but most of us will follow this exact same outline I'm about to give you right now. Now, after I go through the outline, I'll double back and explain why it feels so difficult right at the beginning. Okay, so the first topic you'll start with is called kinematics, and that simply means we will describe how objects move. We will calculate how long it takes to get somewhere. We will figure out where something will end up given a certain amount of time, or we might work backwards and say, hey, this is the final resting place. What were the initial conditions that object started moving with? The key distinction for kinematics is understanding the difference between a constant velocity versus a constant acceleration. Then the second big topic you'll talk about is called dynamics, and this is where we explain why objects are moving. And the key word here is forces, because forces are the push or pull that cause an object to start moving. Thirdly, you'll likely move on to circular motion, in which you'll apply the same concepts from kinematics and dynamics to objects moving in a circle, because it's a little bit different for that type of motion. You may also discuss something called torque. Fourth topic will be momentum and collisions. Key topic for physics because really collisions occur at every scale in our universe, from the microscopic to the galactic. There are collisions occurring inside you right now. Collisions are necessary for all chemical reactions. Okay, then the fifth big topic will be work, energy, and power. And this is really kind of the culmination of this first part of your physics course, because as far as physicists are concerned, everything in the universe is either mass or energy. And once we've defined energy, really everything from this point forward, we're just talking about additional forms of energy. Now, this is where there may be some variation in the course you're taking. So, for example, your course may or may not include something called fluids. You'll study what we call hydrostatics, which means, for example, water pressure of how far. For example, water pressure, meaning if you were at the bottom of a swimming pool, how much pressure would you experience due to the water depth that you're at? The second part of fluids is fluid dynamics, which is the study of how fluid flowing through, for example, a pipe or even the veins and arteries in your body, how that moves. Another topic that may or may not be included in your physics course is thermodynamics. Sometimes thermodynamics is covered under chemistry, but there's overlap here with physics. So that is the study of heat transfer, and it may also include the study of what we call entropy. So that is really the first half of a physics course. in which we talk about objects or particles that move and have energy. The second half of the course, we're going to take a look at a different type of energy called wave energy. Okay, this is energy that passes through a medium like air or water, or wave energy can pass through a vacuum. But the point is here, we're not transferring energy to a particle. We're just having energy pass through something. So the two big examples of waves that you will study are sound and light. And when physicists refer to light, we mean not just the visible light that we can see with our human eyes, but we also include light or electromagnetic radiation that we cannot see, such as ultraviolet light, infrared light, X-rays, gamma rays, radio waves, etc. All of these forms of radiation behave the same way that visible light does, and you will study some of those phenomena. Depending on how in-depth your physics course is, you may also delve into a subtopic of light called optics, which is the study of how light interacts with lenses and mirrors. So if you wear glasses, this will kind of explain to you from a physics point of view why you need those corrective lenses in order to see properly. Okay, the next big topic after sound and light is electricity and magnetism. Kind of put those two together. Doesn't seem obvious at first why we're doing that, but when we get to the end of the topic, it may become more clear. So we'll start with electricity, and first we're going to look at electrostatics, which is, just flip that around, it's just kind of the study of static electricity. Like when you walk across the rug with your sock feet and then touch the doorknob, you get a shock, right? So we'll take a look at why that occurs. That, of course, is not a very useful form of electricity, so we will then move on to current electricity, which is the electricity you're used to thinking about, has the lights turn on in your house, etc. And you will break down different types of electric circuits and figure out how to, as we say, solve the circuit. Then you'll move on to magnetism. I'm sure you've played with bar magnets when you were little, and you know that north and south attract and north repel. And we will look a little bit more in depth into the actual forces involved with that. Finally, you're going to bring those two topics together in what we call electromagnetic induction, which doesn't seem obvious, right? That the two quantities can interact, electricity and magnetism, but they do. And that is really the principle that has motors running, amongst other things. Okay, finally, you'll likely move on to a topic called modern physics, and by modern we mean sort of turn of the previous century, and we'll discuss an introduction to quantum mechanics, as well as something pretty cool called wave-particle duality. Remember I said that first half of the course we're talking about objects that have energy, versus second half of the course we're talking about wave energy. Well, when it comes to light, there's actually an overlap where light can act as both a wave and a particle. So that's a little bit of a mind twist, but very interesting part of the physics course, in my opinion. Okay, so let's double back right to the beginning and take a look at why kinematics might be incredibly challenging for some. So as I said, kinematics is the study of, or the key definition for kinematics is constant velocity versus constant acceleration. And velocity is defined as the change in displacement, the change in position divided by the change in time. It might look familiar to you from middle school where your teacher told you speed is distance over time. Very close. Okay, so that's fine. That's not too bad. But then we get to acceleration. And acceleration, your teacher will tell you, is the change in velocity divided by the change in time. Okay, still not too bad, right? We just have 3 letters here. We can deal with that. Now here's where it gets a little gnarly. So now they're going to tell you, okay, now you got to memorize these 3 formulas. And you know what? You should. It'll just make your life easier from the get-go. So the 3 formulas are V equals V0 plus A delta t, which translates to the velocity equals the initial velocity plus acceleration times the change in time. That's the first equation. Okay, so that's really, if you look at it, it's just a rearrangement of the definition of acceleration is the change in velocity divided by the change in time. So that's not too bad. But here we go with the second one. The second one is delta x, the displacement, equals v0 delta t plus 1/2 a delta t squared. Okay, so the displacement equals the initial velocity times the change in time plus 1/2 of the acceleration times the change in time squared. So now some people might get right away discouraged by that little squared, the exponent. Okay, don't let that bother you too much. You can handle that. All right, so that's the second one. Now here comes the third one. Okay, that is v squared equals v0 squared plus 2a delta x. That means the final velocity squared equals the initial velocity squared plus 2 times the acceleration times the change in position. Okay, so now we got 2 squareds. So that might be a little bit more of a turnoff. I'm not sure. But I can understand why that would be a turnoff right off the bat, because when we were dealing with constant velocity, it was just one simple formula. But now that we're dealing with constant acceleration, effectively we have 4 formulas, and the challenge is sometimes, which one do I use? Well, there is a methodology for figuring that out, but initially, your teacher's correct, you really do owe it to yourself to just figure out how to memorize those 3 that I just listed. Now, on top of that, you're going to need to remember your trig definitions, SOHCAHTOA. You already have that down though, right? Sine, cos, and tan. Just remember the definitions. Of course, you're going to plug those into your calculator to do the calculations. But because you'll be drawing diagrams, you do need to remember what each one is, right? Sine, SOHCAHTOA. Okay. And then finally, you will likely be asked to look at what we call motion graphs. So you remember graphs from math, x-axis, y-axis. X-axis is on the horizontal, y-axis is on the vertical. Okay, in physics, pretty much always time is on the horizontal axis. So time is on the x-axis, and there's something else on the vertical axis. So for kinematics, you'll be looking at delta x on the vertical axis versus delta t on the horizontal. Or you might be looking at velocity on the vertical axis versus time on the horizontal. Or finally, as you guess, you might be looking at acceleration on the vertical versus time on the horizontal. And you'll be asked to interpret, given a graph, what's going on. What type of motion is this object experiencing? Or vice versa, they'll tell you a type of motion and say, well, which is the correct graph that corresponds to the type of motion we just described. Okay, so if you're not really fond of math, I can truly understand why this first topic of physics is going to be a challenge for you. But here's the good news. The good news is when we move past this and get on to the next topic on forces, the formula, there's really only maybe 3 formulas. 2 formulas that you've got to, we'll say 3 formulas you've got to memorize. So, and they're fairly simple. The first is, you probably already know, is net force sigma F equals mass times acceleration. Sigma F equals ma. That's Newton's second law. The second formula you need is just a special case of Newton's second law, which is that weight, or the force of gravity, equals mass times the acceleration due to gravity. The third formula you'll need is the force of friction is equal to the coefficient of friction times the normal force. Now, the challenge for dynamics is more problem-solving methodology and drawing what we call free body diagrams. Now, they're very simple to draw, but it's a matter of interpreting the word problem correctly to draw the correct corresponding little diagram, and then you'll apply Newton's second law, which is simply F equals ma. And then, so my point is, for dynamics, there's way less to memorize. You probably already memorized what I just told you anyways. It's just more practice with the problem solving. So my point is, hang in there, get past kinematics, get onto dynamics, and I think you'll find from that point forward, the rest of the course, there's really not a lot of formulas to memorize. And then the ones that you are given, a lot of them just have 2 or 3 letters involved, 3 variables. So you'll have a much easier time throughout the rest of the course. Now the thing is, though, you do need that basis of kinematics. You're gonna have to come back to those kinematics equations that I already mentioned later on in the course. They keep cycling back for each topic. So kinematics and dynamics form a solid foundation for your study of physics. So, just hang in there. Don't overlook anything, and just practice. Ask questions. Get clarity if you're confused. Just hang in there, and you'll make it on to dynamics. And then once you hit the topic of energy, I think you'll find it a little more smooth sailing. Okay, so best of luck. Post your questions, comments. If you want to just vent, go ahead and do that.